We're now ready to look at the game data assets that don't have set standards in how they can be stored. The developers could have chosen virtually any storage method that suited the needs of the system and the application. Fortunately, we'll be able to tackle these assets with our toolset and common sense. We'll start with the game maps by understanding the contents of the files, figuring out how they work, and decide if we need to convert them to a new format or leave them as they are. We'll start by making a new workspace and copying the maps. Now, at a casual glance, these map files don't seem particularly large, considering the apparent size of the city in-game. We won't jump to conclusions just yet, though. Let's think about what data a map could possibly contain. The most obvious element is layout data. Another possibility is map metadata, such as size or collision boundaries. Maybe special features, such as the headquarters or enemy spawn locations. Now, I would argue that the first point of map layout is pretty much mandatory, whereas the second and third points could be derived from the first, or possibly even hard-coded into the game. And right now, the only hard map element that we can associate elsewhere is the sprite sheet from the BLK files. Let's open the td.map file in the hex editor. It's no surprise at this point that the file has no discernible header. One interesting point is that there really isn't much of a difference in all of the byte values. We can get a better look at this with the Byte Analysis screen. Now, it looks like all the byte values are constrained to only 1/3 of the possible values. It's hard to see the bytes with a small count, but if we sweep across, it looks like 46 hex is the highest value used. Well, 46 hex is 70 in decimal. The largest byte value in the map is 70. Now, if we think back to our map graphics sprite sheet, how many images were in there? Let's go back to the BLK file directory. So we see that the td.blk is 81,920 bytes. And remember, these sprites are 32 by 32. Well, that gives us a total of 80 sprites in the file. However, if we look again at the actual contents of the file with the bitmap we made, we see that the last group of graphics are blank. In fact, there are only 71 graphics in the file, and remember that we start counting in the file at 0, not 1. And if you notice back in the hex file, the last several graphics that did occur in the file had a count of 1. Now, if we believe that those last several bytes refer to the last several bytes of the graphic arranged in the bitmap sheet, we can see that those particular graphics happen to be the sprites for the traffic department headquarters building. There is only one headquarters building on the map. We now have a working theory. The bytes in the map refer directly to the sprites from the BLK files, in the order that they're presented. But we still need to know the size of the map. Let's try to nail this down with a guess. We know the sprites are perfect squares. Maybe the map itself is a perfect square. In PowerShell, we see that the map file is 40,401 bytes. We didn't see a header. We didn't check for a trailer either. Let's take a chance that we're looking at a simple case where all the bytes are only map data. Let's find the square root of the file size. We have a hit, 201. The file size is consistent with bytes arranged in a 201 by 201 square. Let's see what the hex editor has to say. We can't argue with this. This looks like the map to the game, but we're not quite done yet. We haven't checked to see if this map is oriented properly. To do this, we should go back to the game and open the map there. Now, if we look at this top left section of the map, we see an area by itself with the only access being this road that exits to the east. Now, if we find this in the hex file, we see what looks like an exit to the south. Now, this might seem confusing, but there's a good explanation. The map is stored transposed. It has diagonal symmetry with how it's displayed in the game. Now, in reality, there's an easy way to undo this. We should read the map file in as a column major structure. Each byte read in sequentially actually is moving from top to bottom as it's drawn in the game. We now understand how the map files work. They represent a 201 by 201 column major map, where each byte refers to the sprite in the BLK file sprite sheet. So what are we going to do about it? Well, the answer is nothing. Since we know how these files work, we can incorporate the information as is when we develop the prototype without changing the format. Next time, we'll dig into the game dialogue and hopefully understand it well enough also to reuse it without making changes. Thanks for watching.